Welcome to this again, a new learning session on in DWSIM. Now, in this session, we will try to learn about sensitivity study or sensitivity analysis or case study. Okay. Let me open. I've opened already kept my session or DWSIM opened. I am trying to create a new. So let me go to file, and then new chemical process model. I click on this new chemical process model and something turns out to me. So now the window is opening. Yeah. Now it says some introduction. Welcome to the simulation configuration wizard. Click next to continue. I click next. Now I see the compounds here. Select the compounds that you want to add to the simulation. Use the text box to search and select a compound in the list. Click next to continue. So I go to the search bar you find at the bottom of the table, and I keep the system as acetone. I press enter. It automatically gets ticked up, or the checkbox will get a tick mark. Next, I select ethanol. I wanted to select this particular system. Acetone is a ketone group. Ethanol is an alcohol group. Definitely this particular system, because the functional groups are different. So we don't have to assume that it is an ideal system. We can take any other system, or apart from Raoult's law or modified Raoult's law, we have to consider other models. So let me go to the next one. Now you see already it is also saying you can actually choose Raoult's law because the boiling point difference between the two is quite significant. But let me select a unicat model. This is say most popular. I can take all types. I can take equations of state. If I say equation of state, is it actually telling me something? No. I take all types. Anything are there? Yes. So I can take a Wilson equation first. I'm trying to take Wilson equation, and then now the what you call radio button on VLD should be clicked. So because we are working on vapor liquid equilibria, and then click next. Now this is SI system of units. Select the desired system of units for your simulation. You can change individual units by selecting a custom system other than SI, CGS, and engineering. This is what it says. Click finish to exit the wizard and start designing the simulation model. But I can do one thing. This is SI. So I can say this. You can see a button called clone. I can click the clone. It gives me one more what you call with a number SI underscore 10. Now I can change the units. See, this temperature is already in Kelvin. I change it to centigrade because and pressure is in pascals. I convert this into kilopascals. And molar flow rate. Generally, we are accustomed, or in industry we say kilomoles per hour. In industry they even follow liters per hour. But for our convenience sake, or when we actually correlate with the chemical engineering problems, we generally go with the moles or kilomoles per hour. So if I say kilomoles per hour, so I am ready with this particular a mass flow rate also I can change into kgs per hour, and volumetric flow rate also meter cube per hour. So I can say this, or even not meter cube, I can change into liters per hour if it is available. You can check and then do it. So let me actually put this and now, and then I go ahead. So this is I click finish. So now I am ready with for building this flow sheet. So you can see in the top menu, bottom menu, files, flow sheet, dynamic manager, material streams, spreadsheet, charts, script manager. So our window is ready, or we are ready with a basic things. Now I take this. Let us take what do you call a heat exchanger. So I will go to heat exchanger. I take a heater. Okay, I take a heater. I keep the heater here. Automatically the inputs, the outputs are numbered, and as well as directed arrows also. See, the arrow stream 1 is entering into the heat exchanger. Of course, it is obvious that it's an input. E1 is entering into the heat exchanger because I've chosen heater. That means I have to supply heat. So this is also going into the heater. 2 is the output. So what does a heat exchanger does? So it actually increases the temperature. So I click on 1 here, and then my wizard opens. I say this is heat input. Okay, this I say it is a cold stream. because we are heating it. So cold input. Okay, cold process fluid, cold input. That is what it meant actually. So Wilson, my temperature is, this is, I keep it 25 degrees centigrade, and pressure. Now molar flow, let me choose 1 kilomoles per hour. I press enter. Automatically other units are also changes. You can see the mass flow, volumetric flow, all others are specified here. You can see here the Wilson equation. Now stream conditions are over. Let me go to the compound amounts. Acetone and ethanol by default, they are taken as 50% and 50%. But if you want something else, you can change it. But let actually keep it, retain this as it is. Let us see what can be done. We can change this also. Now I say accept. So here the input is 50% and 50%. Now I accept this, and then I go to results. Nothing else. I don't have to see anything here. This is done. So input is done. Now, acha, I have to rename cold process. Okay, cold input, cold fluid input. So I press enter. I have to press enter, otherwise it will not take. Now, stream number 2, I say cold fluid output. So cold fluid output means it is getting heated up. Okay. Now I click on heat exchanger. So this is already inlet stream is given, outlet stream is given, energy stream is given, all things are given there. So what is the calculation type? Heat added or removed. So that is what it says. Any pressure drop is there. It is actually asking us any pressure drop is there. What is outlet temperature? All these things are disabled. But now, what is my requirement? If I click here, if I want to say output, temperature output, okay, what is the temperature output I want? So it is, the input is given at 25 degrees centigrade. I want this to heat it to around, suppose say a 30 degrees rise. That means 55 degrees centigrade. So I say 55 degrees centigrade. I press enter. Okay. So automatically it gives a temperature change in Kelvin, heating and cooling. You can see. Okay. See, but this is disabled. Heating and cooling 1.10034 kilowatt. It is actually giving it. Okay. Now let me save this file. I'm saving this file. Okay. So this is sensitive. Let me not file to heating sensitivity study. Okay, let me say that. See, avoid any spaces or in the file names, all those things, right? Okay, let me say this. Okay, now what is the next step I have to do? The next step I have to do is that I have to solve this. You can see the above, there is in the menu, you can see settings, solve, abort, everything is there. I solve it. Okay, so once it is solved, automatically you can see it is increased. Now, what is the sensitivity study we have to do? What is the next step? So let me go to the flow sheet analysis. You can see the sensitivity study here. Click on sensitivity study, and then I create. This is already created new SEA case 0. Now underneath you see independent variables, dependent variables, results, chart, and independent variables. Independent variable. What is independent variable? I want to actually change. So cold fluid output temperature. What is the temperature? Cold fluid output temperature is temperature, and what is the lower limit, upper limit? So we have given cold fluid output temperature as 55 degrees centigrade. If it is changing, suppose say I change it from 45, the upper limit is around, I don't give 80 because ethanol boiling point is around 78. So let me put it as 75. Okay. Number of points is 5, but let me make it as, or suppose say 20 points, 21. If I say 21, it will be good. I am saying 21 points. So now it is done. Now I have to choose dependent variable here. Let me check this. Click here, plus. You have to add plus, add the object, and then even. I say even. Okay. What is that? Okay, energy flow, units, any units are the kilowatt, it is done. So even we are actually not calculating. It is actually based upon the temperature, it is giving us the results. Let me see. This is what is my understanding, or I might go wrong. Fine, no, there is no issue, because actually there is no acetone, there is no methanol, there is no ethanol, there is no mixture of acetone and ethanol, there is no heater. Even though the temperature is increasing, if I touch the laptop, nothing will happen. Now let's go to the results and then say start. Now see here, you see these things, these two are the names which are given, but these names also can be changed here. But see, sensitivity analysis, start sensitivity analysis. Let us see if anything is done here. See, nothing is being happening. Good. So this is how it has to be done. Okay. Now what is happening? Why it is not getting any change? Let me change it to heat transfer, and anything is efficiency. Yes, you can see this, how much heat added. Let me see. Now if I again run, whether I will get anything change? No, I can do this like this also. Okay, this is also done. Now again I go to the dependent variables. Again you go to dependent variable, heat added. Instead of heat added, I can say minimum pressure, outlet molar fraction, outlet temperature, pressure drop, reset, temperature difference, volume. And I can say efficiency. Let us take efficiency, which has no units, and then again go to results, and then again start. Let us see what is happening. See, completely it is saying efficient, nothing else is happening. But it is actually trying to give us the, what you call, results. Okay. Dependent variable again, let me choose. Okay. Suppose say outlet temperature and centigrade. Outlet temperature we have already given as, input. So this, we are changing the input temperature, outlet temperature itself. So there is no point in giving, or heat added. Let me say heat added, and then kilowatt. I go to independent variables. Now I can say something else here. Anything. Now you can say, now we'll say something cold fluid input, and then property, I say molar flow. I can say this is starting from 1, and then I say I increase the, what do you call this one? So I say 10 kilomoles per hour. Then what will happen? So if I say dependent variable, then what is the heat added? Okay. For the same temperature change, we are trying to actually see one more sensitivity analysis. So let me go to this place again, check what I can now see how beautifully it is actually changing our results in sensitivity study. Wow, this is something good. And how to save this particular table, we'll see in the next video. But let me save this file, and then let me say bye. I hope you have understood how the sensitivity study can be carried out.